In this example, we're going to solve a system of linear equations by graphing. So we're given the system, the green equation, 2x plus 3y equals 12. That's in standard form. That's a linear equation. And then we're given the linear equation in slope-intercept form, the red one, y equals 2/3 x minus 8. So step one is we're going to graph the first equation, and that's green, 2x plus 3y equals 12. I'm going to give you two different options here. We've learned to graph lines using the Intercepts method, where we find both the x and y intercept, plot those 2 points, take our straight edge, and graph the line. We've also learned how to rewrite those equations into slope-intercept form, and then we plot the y-intercept and use the slope value to determine additional points on the line. So it really doesn't matter which way you want to do it, whatever your preference is. So if I want to use the intercept method, we substitute 0 for y, we solve for x, and we get x is 6, so that's the point 6, 0. So I plot that point there, boom. I want the y-intercept, we substitute 0 in for x, we solve for y, and we end up getting y equals 4, so that point is 0, 4. So there's that point. We have enough information, we take our straight edge and graph the line. If you want to rewrite in slope-intercept form, you can do so. First thing we would do, we would subtract 2x from both sides. So we get 3y equals negative 2x plus 12. Then we would divide both sides by 3 because we want 1y, and we'd have slope-intercept form, y equals negative 2/3 x plus 4. So we come over here, we would graph the 0, 4. That's the same point we had before, right? For the y-intercept, good. And then we have a negative 2/3 slope. So that means I would go down 2, right 3. Boom. Down 2, right 3. Boom. Oh, same point for x-intercept. Down 2, right 3. Or I could go up 2, left 3. Again, negative slopes, my line needs to be decreasing. All right. And then I'd obviously connect the dots, and we have that line. So now we would graph the line y equals 2/3 x minus 8. Again, we could do the first method as well and just do the intercept method, but this one's in slope-intercept form. So let's graph it using the slope and the y-intercept. So the y-intercept is 0, negative 8. The b value is negative 8, so there's that point. And my slope here is positive 2/3. So my line's going to be increasing, so I go up 2, right 3. Boom. Up 2, right 3. Boom. Up 2, right 3. Oh, there it is. Point of intersection, right? Up 2, right 3 is a little off my graph. Right? Obviously, I could have went the other way. Down 2, left 3. Take your straight edge, go through all those points, and there is your line. So now we have both lines graphed on the same coordinate plane system here. So our solution is the point of intersection. So we're going to identify the point of intersection. So in this example, our point of intersection there is 9, negative 2. So that means our solution is x equals 9 and y equals negative 2. And again, for my class, typically I'm going to want you to give me the solution. That's just the ordered pair. So I just want to see the point 9, negative 2. And please do not forget the parentheses when you write the ordered pair. We can check our solution algebraically using substitution. So we're going to substitute the 9 for x and the negative 2 for y into the original equation and make sure it gives us a true statement. So the 2x plus 3y equals 12 becomes 2 times the 9 plus 3 times the negative 2. Right? We substitute the 9 for x and the negative 2 for y equals 12. So then we get 18 plus negative 6 equals 12. 12 equals 12, check. But you can't just verify it on one line. You have to verify on both lines, okay? Because you could make a mistake graphing, right? And where it's going to be true for one line, but it's not going to be true for the other line if you made a mistake graphing. So we're going to try it in the other equation. We substitute, again, 9 for the x, negative 2 for the y. So we get negative 2 equals 6 minus 8. Where did the 6 come from? 9 times 2/3. And then negative 2 equals negative 2. True story, verified. This point is the solution to this system of equations.